Okay, so today we're going to talk about 6.4, the applications of linear systems. Okay, and objective for today is to choose the best method for solving a system of linear equations. Or A1.3.3 is our standard. Okay, so the key concept is we have talked about three different methods for solving linear systems. The first one is graphing, second one is substitution, and third one is elimination. Okay, when we want to graph is when we want a visual representation, okay, or when you want to estimate a solution. Okay, that's about when you want to graph. Substitution we would use when we already have one equation is solved for one variable, or it is easier to solve for one of the variables. Okay, elimination process is easier when we want an exact value, when the coefficients of one variable are the same or opposites, or when it's not convenient to use graphing or substitution. So I would say graphing is probably the one we don't really jump to a whole lot unless it's about a story problem. We want to try to find it through a visual representation. Substitution and elimination are probably your two biggest ones you'll use as you go through. Okay, so problem one, finding a break-even point. A fashion designer makes and sells hats. The material for each hat costs $5.50. The hats sell for $12.50. The designer spends $1,400 on advertising. How many hats must the designer sell to break even? Okay, so what does it mean to be breaking even? Well, it means that our income is equal to our expense. Okay, that's what it means to break even. Okay, so when we spend money or we make money, that's either going to give us a positive amount of money or a negative amount of money depending on how much we spend and sell. So that's the big question, is where do we break even? Where do I make just as much as I'm spending? So what we need to do is write an income. So we'll write income is equal to, well, the fact that the designer sells the hats for $12.50. So that's going to be times, let's say, H for hat. And then we have an expense. So the question is, well, how much money is he spending? Okay, well, the materials for the hats cost $5.50. So he's spending that on the materials. So still H for hats, because for every hat he makes, that's the materials he's going to have to need. Okay, but then it's $12, or yeah, it's going to be, $1,400. That's what I was looking for. $1,400 he spends on advertising. Okay, so $1,400 on advertising. So that's our income and that's our expense. So we want to know where we're going to break even. Well, it means where are those two equivalent. So we're going to write $12.50 H is equal to $5.50 H plus $1,400. Now this was real easy because we were looking for a breaking even type of problem. So we just want to set them equal to. It's kind of substitution method. Okay, so this would be kind of substitution. Subtract $5.50 H from both sides. And that cancels. We get $1,400. Here we get, here's all our change, H, and then 12 minus 5 give us 7. Okay, so $7 for every hat is equivalent to $1,400. Divide by 7. We get H equals 200. Okay, so it means he has to sell 200 hats to break even. Okay, 200 hats to break even. Okay, so what I want you to do is I want you to look on the internet. I want you to find a situation where, you know, mostly businesses where you would have a break-even problem, and I want you to write down what those equations would be and then solve them. Okay, so go out on the internet, research it, find something that would work. and put that in. Now it may be like, you're selling lemonade or something. I mean, you need to put something down and then do the research on the information. Okay, problem number 2 is a dairy owner produces low-fat milk containing 1% fat and whole milk containing 3.5% fat. Okay, how many gallons of each type should be combined to make 100 gallons of milk that is 2% fat? Okay, so this is kind of the tougher problem as we go through. We're going to make a system of equations for this, but now we're talking about a mixture problem. Okay, so as we go through, the first thing we have to figure out is, what are we trying to make? Well, we need to set up some equations here, or some variables, so we know what we're talking about. When we're talking about 2% or 3.5% and 1% of milk fat contained in those. Okay, so this would be like X is representing the low fat, and then this would be like the whole milk. Okay, for our two equations. But that's what we need to represent of how many gallons of each. So the first thing is to just go ahead and write the items. So again, a lot of these, as we keep talking about, they go back to items as being one of them. So in this case, the item is the gallons, how many gallons. Okay, 100 gallons between how many gallons of low fat and how many gallons of whole milk. Okay, so now the next thing is we got to come up with that second equation to come up with a 2% of fat. So how much is each one worth? Okay, well, the X, the low-fat milk, is worth 1%, which means 0.01, and then the Y is 0.035Y. Okay, and that combination needs to make 100 gallons, but it needs to be 100 gallons of 0.02. Okay, so that's the setup of this problem. So if we multiply that, we get 2, and then we get 0.01x plus 0.035y. So really, this equation, we just simplified it down to this. Okay, so now what method would probably be the best thing to use? I would say graphing, probably not. Elimination, probably not going to be real simple to do. It could be if you multiply by 100 here, but really it might be just to solve for one variable and plug it in. So we might say like 100, let's say x equals 100 minus y if we subtract y, and it gets us 0.01 times 100 minus y plus 0.035 y equals 2. And now we just solve, which gives us 1 minus 0.01 y plus 0.035 y equals 2. We could just take the 1 over, which makes that 1. Combine these two, which is a negative 0.01, which gives us an 0.25y equals 1, which means that if we multiply or divide by 0.025, we get y to equal 40. So that means we need 40 gallons of whole milk, which means 100 minus 40 is 60, so we need 60 gallons of low fat. And that would be our answer for the mixture problem. So it starts off with items and then how much each one's worth. And so the worth is really the mixture here and here. But then we want 100 gallons of 2%. So that's where that 2% comes into play, is what we're equal to. Okay, so example 4, you're dealing with antifreeze solution is 20% alcohol as you go through, in that case, 15 liters to make 18% alcohol. Okay, so that's where that 0.18 is going to come into play. Okay, try that one, see where you're at, and we'll make corrections tomorrow. Okay, another key concept we have here is traveling. Okay, so we have to deal with wind, airspeed, and wind speed helping us. So if we're going west to east, you're traveling at an airspeed, but then the wind's pushing you and actually making you go faster, and that gives you a total what your ground speed would be. East to west, you're going against the wind. So what's happening is your airspeed is going so fast, but then the wind is pushing you back, and that's actually going to make your ground speed a little bit slower in that case as you go through. Okay, so using that last slide as reference, we're going to work through problem number 3. Traveler goes from Charlotte, North Carolina to Los Angeles. At the time another traveler goes from Los Angeles to Charlotte, their airspeed of each plane is the same, so they're traveling the same airspeed. The ground speeds are 495 miles per hour for North Carolina to California, and California, North Carolina is 550 miles per hour. What is the speed of the air? So what we have to do is say, well, if we're going from California to North Carolina, it's going to be our airspeed plus the wind is going to equal our ground. And then from North Carolina to California, what's going to happen here is we're actually going to have our airspeed minus what the wind's pushing back on us is going to give us our ground. So now we just have to put things in here. A is going to stay A. Okay, our ground speed for California to North Carolina was 550. And 495 for the North Carolina the other way. So we have air plus the wind, and then air minus the wind. Now what we want to solve for is our airspeed. So really what we want to do is we want to eliminate the W. That would be the quickest way to get there. If we eliminate the A, we're going to have to solve for W and then plug it back in. So here we have it set up perfect. So we just write A minus W is equal to 495. And since they're 1, 1, but opposites, we can add down, which gives us 2A, cancels, gives us 5, 4, 1045 for our speed. Divide that by 2. We get A equals 522.5, and this is going to be miles per hour. That's our airspeed. So notice how we solved straight for the air. We didn't have to go back and find the wind. Okay, for that first part. Okay, now if we want to find the wind, they want to know what the wind speed is. Now we just go back in and plug that value in. So we could go into this one. That's fine. Do 522.5 minus W equals 495, and we can figure out what that wind speed is, which is going to be 27.5, which would be negative to start, but then it would have to be divided by the -1. So our wind would be 27.5 miles per hour, and that would be our wind speed by just plugging it back in. And I just use this one because I put it right underneath. You could use this one as well. Doesn't matter. Okay, so that's it for this lesson. We'll pick up tomorrow in class. Again, you have a pre-quiz. You finish that up, and worksheet and stuff in class that we'll do.